We will now do examination questions on astronomy and cosmology. But before we do that, we discuss some of the things you must know. For A, you must know some of the definitions of luminosity represented by L, radiant flux density, F, standard candles, Doppler effect, and you also must know the definition for Hubble's law. You can see that the list of things that you must remember here is not comprehensive. There are certain things which is not included here. B, the laws that you must remember. You must remember Wien's law of displacement, which states the relationship between the color of the star controlled by lambda maximum and the temperature T of the star. So lambda maximum times T equals to a constant. Then number 2, you must know Stefan-Boltzmann law, which states the relationship between luminosity, surface area, and temperature of stars. This is a formula. Then you must know the Doppler's formula to calculate the velocity V. Change in your wavelength divided by wavelength approximately equals to the change in frequency divided by the frequency, approximately equals to the velocity of the object which is moving divided by the speed of light. Then you must be able to state Hubble's law, which gives the relationship between interstellar distances d and the recessional velocity v. And this is a formula for Hubble's law. C refers to the calculation you must be able to do. Number 1, you must use the relationship between L and F to calculate interstellar distances. The formula used is L equals to 4 pi d squared times F. L can be obtained from the static candle, whose luminosity is known. Then F can be measured on Earth. Therefore, you can use your formula D equals to L over 4 pi F to calculate your D. Then, in order to calculate interstellar radii, you need to use Wien's law and Stefan-Boltzmann law. From your Wien's law, we know the temperature. We will know the temperature T of the star from the maximum wavelength produced by the star. Then we use L equals to 4 pi r squared, Stefan constant T4 to find R. Because luminosity is known, your temperature is known from your Wien's law, so you can find your R. Then number 3, use Doppler's effect to calculate recessional velocity V. And then number 4, use Hubble's law to show that the universe is expanding. And this leads to the Big Bang theory. Hubble basically do 2 things. He used Doppler equation to find the velocity. And then he used the velocity against D graph to state Hubble's law. To come to a conclusion that recessional velocity is proportional to the distance of the star from Earth. This question comes from the specimen 2022 paper. Question number 12. A star has a luminosity that's known to be 4.8 times 10 power 29 watts. A scientist observing this star finds that the radiant flux density of light received on Earth from the star is 2.6 nanowatts per meter square. Name the term used to describe an astronomical object that has a known luminosity. The answer is a standard candle. Then you have to find the distance of the star from Earth. This is the formula we use. So D is what we want to calculate. So D equals to the square root of L divided by 4 pi F. Then you substitute the values given in the equation into this expression. You will get D equals to 3.8 times 10 power 18 meter. Then in part B, the sun has a surface temperature of 5,800 Kelvin. The wavelength of light, the maximum wavelength of light for which the maximum rate of emission occurs from the sun is 500 nanometer. The scientists observing the star in A find that the wavelength for which the maximum rate of emission occurs from the star is 430 nanometer. Number part 1 shows that the surface temperature of the star is approximately 6,700 Kelvin. Explain the reasoning. To do this question, they use Wien's law of displacement, which states that your lambda max is proportional to 1 over T, or you can say lambda max is inversely proportional to temperature. Therefore, your lambda max times temperature equals a constant. So you can write one equation for the sun. 500 is the maximum lambda max. And then this is the temperature of the surface temperature of the sun. It was a constant, equals to 1. Then we do this for the star. Then we equate number 1, number 2. This is how you get this expression. Then from there we get T equals to 6,700 Kelvin. Then use the information in A and B part 1 to determine the radius of the star. The equation you use is this Stefan equation. We want to find R. So you must know your L. L is known. Your temperature is calculated. Then you can substitute the values into the equation. You get 1.8 times 10 to the power 10 meter.